Okay, so sin x is a increasing function, right, in first quadrant, and cos x is decreasing. Okay, because x1 is decreasing.
Yes.
When you move from here to here this way, x1 is going to decrease because x1 on the x-axis, x1 axis is r, because the length of the stick is r. When it touches this x1 axis, the length is going to not change. So x1 is r and y1 is 0. As you move up, x1 is going to decrease, right?
Yeah.
Y1 is going to increase. Y will increase, y1, x1 will decrease, right? So that's why sin x is going to increase and cos is going to decrease.
Yeah.
Now,
Okay.
in the actual plot of it will look like this. X. So sin x is going to increase, right? Sin x will go like this, and cos will start with 1. Cos is 1 at 0.
Yeah.
So this one is sin, and this one is cos. So 1, the value here is 0, and this is pi by 2. And this is the behavior of sin and cos. What about tan? Tan x in the first quadrant, increasing or decreasing? Tan is y1 by x1. And what is happening to y1? Along the green arrow.
Y1 is increasing and x is also increasing.
X1 is decreasing, no?
Oh, right, yeah. So then tan will be increasing.
Yeah, it's much more faster because numerator is increasing and denominator is decreasing. So both are contributing to increase. If you take sine, numerator is increasing but denominator is constant.
Yeah.
But here, numerator is increasing and denominator is decreasing. So it will increase much faster. The plot of tan will look like this in the same plot. At pi by 2 will become infinity. Because tan is y1 by x1, right? As you go closer here, okay, the value of x1 is very small. Okay, and y1 is close to r. So r1 divided by a very small quantity, it is going to shoot up.
Yeah. Okay.
Okay. So right, and tan is also equal to sine by cos. Because sin x is opposite by hypotenuse. Yes, cos is adjacent by hypotenuse. So when we divide both of them, we get opposite by adjacent, and that is tan. Right. So sine by cos, with the denominator cos becoming 0, this thing will shoot up, right? Anything divided by 0 is a large number.
Yeah.
And sine is becoming 0 at this point. Pi by 2 minus, it's becoming very close to 0. That's why at that corresponding point, tan is very large. This is tan x.
So tan is much larger than sine and cos.
Yes. When you divide something by a very small number, that value will increase, right?
Yeah.
So tan is sine by cos. Cos is becoming small as you approach pi by 2. So that's why tan is shooting up.
Yeah.
Okay. This is in the first quadrant. Okay. Now sine of minus 6 equal to minus sine x. How do you understand this one? What does the minus angle mean?
It means it's in the bottom quadrant and it's traveling left.
This is x, angle x. like x-axis, you have positive side and negative side, right?
Yeah.
So similarly, angle you can measure in two directions. Let me call this x1, y1. So if you measure angle in this direction, that will be negative. This is minus x. Okay. So suppose if you choose a point at an angle x, and the coordinates are same, x1, y1. What will be the coordinates of the point here? Actually, I have not gone into that.
Minus x1, y1.
Actually, y is minus, no? X1 is same. X is same, no? X is this point. That is same for both. And y1 is minus. Suppose if this is plus 3, this thing will be minus 3 because this is negative y-axis. This is y equal to 0. Here it will be negative, minus 1, minus 2 like that. Here it will be plus 1, plus 2 on the top. So y1 is negative. X is same, no? Because this is same length. This is x for both the points.
Yeah. Okay.
And for the above point, y is this one. And for the below point, y is this one. So when you go down, the value of y is negative. So this is the corresponding value of y1 of this point. So this is negative. Here it's negative. And here it is positive. This is positive. And here it is negative. So that's why the coordinate of this one is minus 5.
Oh, okay.
Okay, x1 and y1 are both greater than 0. y1 is coordinate of this point. If you take that as y1, this will be minus 5. Okay, so sine of angle x is, using this point, I'll get as y1 by r. And sine of angle minus x, using this point, I'll get it as minus y1 by r. Okay, so from this I can write as minus y1 by r is sin x. So I've got this relation here. Sine of minus x is minus sin x. Okay. Similarly, cos of x. Cos x is what? X coordinate by r, right? So cos of x is x1 by r. And cos of minus x is again the same. Coordinate does not change. So this is also equal to x1 by r. So that is why cos of minus x is same as cos x.
Okay.
Okay. So when you take cos of a negative angle, the minus sign is absorbed. It disappears. When you take sine of a negative angle, the minus sign comes out.
And the other
Sine of negative angle, the minus sign will come out.
Yeah.
But for cos, the minus sign will disappear. Right?
Yeah.
Now what about tan minus x? Tan x is y1 by x1, right?
Yeah.
And tan minus x is minus y1 by x1. So this is equal to then minus tan x. Same way. Tan is y by x or y1 by x1. Tan of minus x is minus y1 by x1, which is equal to minus of tan x.
Yeah.
So even in the case of tan, minus sign will come out.
Okay. Yeah.
Another way of understanding this is tan of minus x is sine minus x by cos minus x. Tan of any angle is sine by cos. The angle here is minus x.
So tan minus x will be sin minus x by cos minus x.
No, tan of any angle is sine by cos.
Yeah.
So here that angle is minus x. So whatever is the angle, I just put it here.
Okay. Yeah.
It doesn't matter what the angle is. Tan alpha is sine alpha by cos alpha.
Mm-hmm.
So on sine of minus x, we already know the minus sign will come out, and cos will just absorb the sine. And sine by cos is tan. This is minus tan x. So this is also you can prove that tan of minus x is minus tan x.
Mm-hmm.
Okay. So even in the case of tan x, the minus sign will come out. Only cos it will disappear. Right?
Okay. Yeah.
Okay. Now, okay, in coordinate geometry, you know the distance between 2 points. If you have 2 points, this coordinate is x1, y1, and there's another point whose coordinates are x2, y2. Okay, what is the distance between these two points? You know how to find the distance, or you already know the formula.
No, I don't know.
Okay. Suppose you draw a horizontal, and this one, this will be 90 degrees. X-axis is here, and this is y-axis. Okay. So, how much is this distance?
Um,
Okay, from here to here, how much is the distance? Horizontal distance.
x1.
Yeah, and another distance is x2, right? From here
Yeah.
to here is x2.
Yeah.
Then what is this distance then? This one,
Mm, x2 minus x1.
right? Similarly, what is this distance?
Y2 minus
Yes, yes,
y1.
yes. Because y1 is the full vertical distance. Got the idea, no?
Yeah.
Y2 is this one, and y1 is this one.
Mm-hmm.
Okay, so from there you get this one is y2 minus y1. Okay, now what is the this distance?
That's y2.
No, you have to use Pythagoras theorem.
Oh, this distance.
Because yeah, these x1 y1 lines are parallel to x-axis and y-axis. Okay, this is a
Okay.
slant line. Slant line you cannot think like that. So for that you have to use Pythagoras theorem because you know the
So
legs
y2
of
plus y1 squared
uh,
plus x2 minus x1 squared.
yeah, that's right. Right. So in short, I'll write it as delta x square plus delta y square square root.
Mm-hmm.
Yeah, you understand, right? This is delta y. Just for short notation, I'm writing. This is delta x. It's fine, right?
Yeah.
Okay. Okay. Now we use this formula for this thing. Right. One more thing you have to understand. This is a circle of radius r. Okay. And I'm taking a line at an angle theta. Okay. So what are coordinates of this point?
Uh,
if I need coordinate, I just have to drop a perpendicular. Okay, I need this distance. Okay, and this distance is the radius of the circle r. So what is this distance then? The blue line. What I have written?
R cos theta.
So is that distance r cos theta? If you take cos theta, it is adjacent by hypotenuse, right?
Yeah.
Adjacent, okay, hypotenuse is r. So adjacent will be r into cos theta.
Oh,
Yes.
so yeah.
Got it?
Yeah.
Cos theta equal to adjacent by hypotenuse is r. So from that I get adjacent as r cos theta. Straightforward, no? Definition of cos theta is adjacent by r because r is hypotenuse. From that I'll get adjacent as r into cos theta.
Yeah. Okay.
So similarly, what is the vertical distance there?
That would be r sine theta, right?
Yeah, this is r sine theta. Okay, then the coordinate of this point is what? R cos theta comma r sine theta.
Yeah.
And if I choose this radius as 1, then the coordinate will be cos theta comma sine theta. I can instead of drawing a circle of radius r, I can draw a circle of radius 1. Okay, so if I choose my point on that circle of unit radius, then the coordinate of the point will be cos theta comma sine theta because r is 1.
Yeah.
Okay, so here in this thing which you are trying to derive, so what do you notice first of all? Just a minute, I'll come. What do you notice in this formula? One side, what is the angle?
I can't see what you're pointing at.
On the top, we have this formula,
Oh,
right?
yeah.
Identity. So on the left side, what do you see? What is the,
Cos x plus y.
so what is the difference between left side and right side? Left side, what is the angle?
Cos.
No, just the angle. Just the angle.
Huh?
Angle, forget cos, sine and all. They are ratios. Angle is x plus y, right?
Yeah.
On the right side, what are the angles?
X, Y.
Yeah, x and y.
Yeah.
So on the left side, we have sum of angles. X and y are angles. On the left side, there is a sum. Okay. Right side, there are individual angles.
Yeah.
Forget cos and cos multiplying. That is different. I'm just talking about the cos of something, sine of something, right? Those angles. On the left side, we have a sum, x plus y. On the right side, the individual angles. So this formula is relating the sum angles to the individual angles. When you take cos of x plus y, it is cos x, cos y minus sin x and y. And we are trying to prove this one. Okay. So in this figure, the horizontal axis and vertical axis is there. So this is angle x. Get it? From horizontal axis to this point. This is angle x. And angle y is measured from here to here.
Yeah.
Okay. And angle minus y, since negative angle, it's measured in the clockwise direction. It is from here to here. Right?
Yeah.
Okay. So first angle is x, and I'm reaching this point. This point. Okay. So the coordinate of that point will be cos x sin x. That's what I showed here, right? Coordinate of a point making angle theta is cos theta comma sin theta if r is 1. Okay. Here I've chosen unit circle. So the coordinate of this point is cos x sin x. Is that clear? Okay. So the coordinate of this point minus y, the one which is making angle minus y, is cos of minus y and sin minus y.
Yeah.
Okay. And there is one more line which is making angle cos x plus y with the horizontal axis. So the coordinate of that point is cos x plus y sin x plus y.
Okay.
Because the angle is always measured with the horizontal axis in the positive direction. Okay. Since x and y are been chosen for angles, I call this horizontal axis as u and the vertical axis as v. Okay, just a choice of variables. It does not make any difference. So my UV axis and that x and y are using for angles. Okay, so here you can observe two triangles which are congruent. One is this triangle and the two radiuses, and the other one is this triangle with the two radiuses. Clear?
Yeah.
So, so the two orange lines which I just shaded, those two should be equal, the lengths.
Yes.
Okay, and the first vertical orange line, which is between P1 and P3. Okay, so the length P1, P3 should be same as length P2, P4.
Yeah.
Yeah, and also the length of P1, P2 square, sorry, P1, P3 square should be same as P2, P4 square. Length same means the length square also same, right?
Yeah.
If 3 equal to 3 means 3 square equal to 3 square, right? Like if x equal to y means x square equal to y square. Okay, so the square of this length is given this distance formula P1, P2, P1, P3 square is x coordinate difference, that is delta x, that is cos x minus cos y. Cos x minus cos of minus y, and then sin x minus sin minus y. Sin x minus sin minus y square. Okay, and similarly P2, P4, it is 1 minus cos x plus y square, 1 minus cos x plus y square, and then 0 minus sin x minus y square, x plus y square. Right?
Okay.
Okay.
Yeah.
The coordinate of this point P4 is 1 comma 0 because it's on the y axis, vertical axis, b axis. So the y coordinate or the b coordinate is 0 and the u is 1 because it's a unit circle. Unit circle means radius is 1. So this coordinate is 1 comma 0. That's clear, no?
Yeah.
Okay. Now we just have to expand this one. First of all, cos of minus y, the minus 1 will disappear, right?
Yeah.
That's what has happened. Let's just become cos y. And sine of minus y, minus 1 will come out and this thing will become plus.
Oh, okay. So both the sides.
Right? Now we have to use A minus B formula to get this one. Okay. And then A plus B formula for this one, the second one.
Yeah.
Right? And then you have to combine this one. Sine square x plus cos square x is how much? Sine square plus cos square?
Uh, it's
1. Yes,
Oh yes, cos square is always 1.
and similarly sin square y plus cos square y. That's another one.
Yeah.
So those two will give us 2.
Okay.
Okay, and the remaining this one minus 2 cos x cos y and plus 2 sin x sin y is being written like this.
Okay. Yeah.
Right. Similarly, the next one again you have to take out the minus. Okay, here there is no. Okay, this is just a minus b square. Get it right? This is the first one, and the second one is just this one.
Okay. Yeah.
Yeah, and then you have to again there is one sin square plus cos square. You can see one sin square plus cos square. Sin square of any angle plus cos square of the same angle will be 1. Sin square plus cos square of the angle x plus 1. So there is one, and there is one more one here. That will give 2, right? And the rest you have to drop it.
Okay.
Now you have to equate this one and this one because the triangles are congruent. So from that you will get cos x plus y as cos x cos y minus sin x sin y.
Okay.
That's
Yeah.
what
Got it.
that's what we are trying to prove here.
Uh-huh.
Okay. So these are the basic things. You have to take a unit circle, one line making an angle x and y the following one, or it is making angle x plus y with the horizontal positive axis. Another line with the angle minus 1. And coordinates of a point on a circle of radius r, making an angle theta is r cos theta, comma r sin theta. And here you're taking unit circle, right? So this is the derivation of the formula cos x plus y equal to this one, right? Now I want cos x minus y. How can we derive this one?
Uh. Hmm.
Same way you will take a circle. Previously we took a circle no, for cos x plus y. Okay. Now for cos
Yeah.
x minus y, shall we take a similar circle?
Okay.
Okay. Instead of that, what you can do is in the previous one, put y equal to minus 1. We already had the right formula for cos x plus y, right? So in this, instead of y, you put minus 1.
Okay.
Okay, so that you don't have to do the hard work again. So instead of saying x plus y, let me say I have formula for cos a plus b. Just change of variables. The structure is cos minus sin. So you have to remember the formula. And the order of angle is same, AB. Cos a plus b formula is cos minus sin. And the angle will be AB. Order. Cos a plus b is cos minus sin. And the angles are AB. Instead of x sin A. Okay, just change the variables for convenience. So here in this one, I'll put A equal to x and B as what? What is my B?
Y.
No, minus y. Only then I'll get x minus y, right?
Minus y.
So B is minus y. So here it will be cos x, cos minus y, minus sin x, sin minus y. For cos, I'm just using symbol C, and sin, I'm using symbol S. And the angle, I'm putting a suffix. No confusion, right?
Yeah.
Okay. And what is cos minus y? In cos, the minus sign will get absorbed, right? It will disappear. So this is same as cos y. And sin, the minus sign will come out.
Wait, it's the same as cos square or cos plus y?
That's what that's what we saw here, right? Sine of minus x, minus sign will come out. Cos of minus x, minus sign will disappear. Tan of minus x is again minus sign will come out. So only for
Yeah.
cos, the minus sign will disappear. For sine and tan, the minus sign will come out.
Okay.
Okay, that's what we're using here. Cos of minus 5, minus sign is disappearing. Sine of minus 5, minus sign will come here. So this is equal to cos x, cos y plus sin x, and this minus sign I'm combining with this one, it will become plus. So I have proved this one. Okay,
Okay. Mhm.
only cos a plus b have to do this circle and do the hard work. Okay, but using this we can prove a minus b formula, cos a minus b or cos x minus y by choosing appropriate values of the angle. Okay, what about this one? Cos, how do you prove this one?
Cos pi by 2. Uh,
Use this one. Using this one, how do you get this one?
but there's no pi in that one.
Okay, so what you have to do is for x you put pi by 2 and for y you put x. Okay, to avoid confusion, write formula for cos a minus b. The structure is cos cos plus sin sin. And the angles are AB.
AB.
This is how to remember the formula. In A minus B, there will be plus. Okay. So here in this, A put A equal to pi by 2 and B as x. Okay. So this will become cos pi by 2 cos x and then sin pi by 2 sin x. Cos pi by 2 is how much? Pi by 2 is on this axis, no? Y axis.
Yeah.
So cos of this point is how much? 0. Because it's x by r. The value of x on the y axis is 0, right?
Yeah.
And sine is 1. So the whole thing is equal to sin x. That's what is here. So I have proved it.
Oh, okay.
Okay. How do you prove the next one? You have to get it from here. From this, you have to get this one. Okay. In this one, if you put x equal to pi by 2 minus x, you will get sin pi by 2 minus x, right? So the above formula,
Yeah.
you write it like the sin pi by 2 minus a equal to sin a. That is the formula above, right?
Yeah.
Okay. Here you put a equal to pi by 2 minus x. So then you become cos of pi by 2 minus pi by 2 minus x, it will become cos x equal to sin pi by 2 minus x. So you approve this one.
Okay.
Right?
Yeah.
Okay. One way of remembering this formula is this angle is theta. What is this angle? Right angle triangle. So this is 90 degrees. So what is this angle?
And
Is that right?
yeah.
Sine should be 180, total should be 180, right?
Yeah.
So the other two angles should sum to 90 degrees. So they'll be complementary. Okay. So, and suppose the sides are ABC,
Mm-hmm.
A, B, and C. What is sine theta? A by C, right?
Yeah.
Sine theta is A by C. And what is cos pi by 2 minus theta?
Uh, uh, wait.
Sorry, cos theta is B by C. Cos theta is B by C, the opposite side.
Yeah.
And what is cos pi by 2 minus theta? Which is equal to sine pi by 2 minus theta. Sorry, cos pi by 2 minus theta is same.
Uh,
Cos of an angle is adjacent side by hypotenuse, right? For pi by 2 minus
yeah.
theta, adjacent angle is B.
Yeah.
So it is B by C. Hypotenuse is not going to change. It's always C. Okay. And for angle theta, B is opposite side.
Okay.
So sine theta is B by C. And cos pi by 2 minus theta is again B by C. So that's why sine of theta and cos of pi by 2 minus theta both are same. They are complementary angles, right? Theta and pi by 2 minus theta, they are complementary. You know complementary angles, no?
Yeah, two angles that add up to 90 degrees.
So theta and pi by 2 minus theta are complementary.
Yes.
So that's why sine theta is cos pi by 2 minus theta. Similarly, the other way around, cos of pi by 2 minus sine pi by 2 minus theta will be cos theta.
Oh, okay. Got it. Mm-hmm.
This is a way of remembering the result. Okay, we'll continue next time. Right. Any questions in this one?
So,
Bye.
bye.